we are pleased to move on to competitor number 5 this evening, who is Saptarshi Biswas from the Department of Biomedical Engineering. Saptarshi.
Imagine a soldier taking a bullet for his country and is unable to get proper patient care, which can cost their life or damage an organ for a lifetime. Surprisingly, till now, blood loss causes more than 80% of battlefield casualties and 40% of death in civilian setting. Surprisingly, the problem with the blood loss is that the treatment gets more challenging when the injury occurs in the internal body organ, lacking a surface to put pressure on. These injuries are not accessible to conventional pressure dressing, eventually increasing the mortality. Therefore, there is a pressing need to develop an alternative strategy to combat hemorrhage in the internal body organ. Now, what if I tell you that being a biomedical engineer, we have the power to create something that can save lives? In the Gaharwar lab, I am developing a combinatorial strategy using a foam and a smart biomaterial-based matrix to combat hemorrhage. Now, the question is, what advantages does this system offer? First of all, due to the rapid expansion of this foam, the composite will fill in the wound cavity, providing a surface to apply pressure dressing. On top of that, due to the presence of this biomaterial-based matrix, it will help to concentrate blood clotting factors as well as activate the blood cells at the same time. I hypothesized that due to the synergistic effects of both foam and the biomaterial-based matrix to fabricate the composite, it will clot blood in a much faster way. And the results are promising. I observed an incredible 5 times expansion of the composite within 3 minutes while activating different blood cells. And this composite degrades much faster, as well as we did not see any detrimental effect of this composite when in contact with human skin cell. Upon delivery of this composite in animal model, we observed an incredible 80% reduction of the clotting time, and the blood loss also reduced to 50%. That is fascinating, right? Making it an excellent hemostat. Now, bacterial infection is very closely associated with hemorrhage. Therefore, while developing a futuristic hemostat, maybe clotting won't be enough. That got me thinking and is pushing me to driving my research to evaluate the wound healing efficacy of this formulation. Now imagine an all-in-one product with excellent hemostatic and wound healing ability, ready to help patients in both battlefield and civilian setting, and making it an alternative therapeutic strategy for better clinical patient outcome. Thank you.